So today we're still graphing quadratic functions, but the form is different. It is something called vertex form. And what vertex form uses is a method known as a transformation. You're using a transformation to basically think of, say, okay, what did we say a parabola looks like? Huh? Yeah, it looks kind of like a U, right? So in effect, you might not realize you're doing it because we're going to do it algebraically, but in effect, what you end up doing is saying, all right, we're going to get that U-shaped parabola, and we're going to stretch it and slide it and flip it and like manipulate it based on the numbers that surround it. Okay, but in order to be able to transform that parabola and do these stretches and flips and slides and all that other good stuff, you have to say, okay, what does f of x mean? Y. So if all we had was a y that was equal to an x squared, that would generate a set of points. If I plug in an x, I get a y. Like for instance, if I plug in a 0 for x, what's 0 squared? If I plug in a 1 for x, what's 1 squared? If I plug in a 2, what's 2 squared? 4. So that gives you, every time you substitute and get an input, output, input, output, input, output, that gives you an ordered pair. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, so on and so forth, as long as you have enough space to graph it. In each case, I was giving you a pair of numbers that when you square one, that's what gives you the other one, right? That's what you see on the board here. So now, think of these as like starting points. Okay, because these are points that are generated only when you square the x. But now we can surround, and I was thinking about it, with parabolas, once you do, I already printed the notes and I wasn't going to print out another 100 packets, but this little C here, that's not going to have an effect on the parabola. So I think I prefer to erase it. That only has an effect on certain functions. So just write this instead. Just make it easier for you to understand. I'm either going to color code. So yesterday we started off with standard form, and standard form is what you were really familiar with, that ax squared plus bx plus c. This is the vertex form of a parabola. Notice how we still have the square. Don't forget to put the square there. The square was already there on the pre-printed form. Had you erase the C because it's one less thing to worry about. So, look, I even color coded it for you. What do we see in blue? Yeah, we see A, H, and K because other than if you compare my starting points, if all I'm going to do is square a variable, I have a y, an x, and the square. If I now look at vertex form, I have a y, an x, and a square. But besides that, the new numbers that I'm introducing, which are the numbers that are going to get that parabola and stretch it and flip it and slide it and do all that other good stuff to it, are A, H, and K. And guess what? We recognize all of them. Where do you recognize A from? You saw it yesterday. Yesterday, A was the number all the way out in front. Today, A is a number all the way out in front. And the good news is they're exactly the same. This A is exactly the same as yesterday's A. What did we learn about A yesterday? How is A significant with the way the parabola looked yesterday? If it was positive, parabola faces up. If it's negative, parabola faces down. Same thing today. That hasn't changed. Okay? But we'll learn that this A can actually do a couple more things too. Okay? It's what actually, this A is what makes the parabola either look tall and skinny or short and fat. Hey, look at those other two letters. Well, H and well, the letters are H and K. And even though maybe you didn't really kind of understand why we were using H's and K's yesterday, now you should. Because what this is telling you is when you are in vertex form, the number that you see where the H is and the number that you're going to see where the K is, that is going to be, as Ellie said, that's going to be the vertex. So the vertex is going to be given to you as long as you're in vertex form. What point were you given yesterday? Yes? Yeah, yesterday you were given the y-intercept. What was the y-intercept? It was the C, right? Well, today you're going to be given the vertex is going to be H and K. But wait, but I'm so confused. I don't get it though. But like, how am I supposed to know if I'm in vertex form or in standard form? Well, there's one other little slight difference between what you saw yesterday and what you saw today. What do you see today that you didn't see yesterday? So, the parentheses. If you see the X inside of a parentheses, then it's considered to be vertex form. Even if you don't see a parentheses, if you only see an X that's being squared, you could still consider it to be vertex form. Like you just couldn't have that extra X. If you have that BX term, no, then that can't be considered to be vertex form. Like remember when we did square root property and we talked about like when there's only one single X or when there's two different X's. So as long as there's not two different X's, even if you don't see a parentheses, you could still consider it to be vertex form. It's just that H would be 0. If you don't see a parentheses, H is 0. So let's talk about some aspects of the vertex. A lot of these we already know. I'm used to teaching this first and then standard form second. So actually a lot of the stuff that I'm going to show you here we already know. Such as a vertex can either be referred to as a min or a max. When is a vertex referred to as a min? When the parabola is facing up, which is when A would be positive. When is a vertex referred to as a max? When it's facing down. So A is positive and it's upright. This little thing here at the bottom, and just like yesterday where I was amazed and I even told all the rest of my classes about the wonders I had seen in second period where kids actually wrote things down that I said as opposed to just only writing what's on the board. Yes? Huh? Say that again? Yeah, well, because I didn't know how to write it. The reason, because I wrote a U, because like normally I teach this first, right? So, and I was actually another thing I was surprised about. A lot of you already knew what a parabola was. But no, a lot of people when I teach this, the kids have never heard of a parabola. So they think of it as the U. Well, but if I put it backwards, it's not a U. It's like when I wrote downward U, it's just saying that the U is facing down. If I wrote downward and then I put another like facing downward, then it would be redundant. It would be. Have I confused anybody with that? No. That's why I put it like in quotes. It's like, oh, it's the U thing, parabola. You confuse yourself. Anyways, the reason I put this y equals k thing, feel free to write this down, is because depending on the way the question is phrased, but a lot of times when you're being asked for, hey, what is the minimum or maximum value of the function, when they use those words, they're not really talking about the entire vertex. They just want the y. So what this is telling you is, what do we call the y of the vertex? We've been doing this since yesterday. What name did we give to the y of the vertex? No, the y was k. The h was x. So this is just telling you that when that phrasing is used, min or max, most of the time they're really just referring to the y of the vertex. But then depending on how it's worded, they might want both the x and the y. Okay, this we already know from yesterday. The axis of symmetry is going to be located at x equals h. The difference today is that we don't have to find h. H is going to be given to us. How do we make these transformations, right? Because how many points do we need in order to graph a parabola at minimum? We need 3. Okay? We absolutely need the vertex, but the difference is, yay, today they're going to just give it to us for free. The last point, we're going to still use that axis of symmetry to flip it over. We're going to use an axis to flip. But we still need one extra point to find. Well, yesterday we used substitution. Today we're going to use transformations. This is the formula that we can use to transform a pairing function. So, and because I got rid of this c, go ahead and just write it this way. X plus h and y times a plus k. Oh wait, I don't get it. Like, okay, I recognize a, h, and k, but where do I get x and y from? You can get x and y from any of these x's and y's that are here. The only one that you can't use is this one. You can't use 0, 0. But any other x and y that you see there, you can use. There's even some x's and y's that you don't see that you can use. What are some other ones that we've talked about? That we talked about at the beginning today that belong to the function of if all you're doing is squaring the x, what are some other points you would see? Besides 1, 1, and 2, 4. Yes, Louis. 3, 9, sure. What are some other points? 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, and 100. But you're not going to really want to use those because what happens is the further away you get from the vertex, now the bigger your graph has to be. And we don't want to have to use a huge graph. So most of the time you're going to use one of these. Maybe even 3, 9. You know, really, most of the time I just use 1, 1 to start off with. The only time I wouldn't maybe is if depending if they give me a fraction for a, h, or k. But we'll talk about that in the examples. All right, let's start exampling it up. This first example here, we have 4 different functions all written in vertex form. How do I know that they're written in vertex form? The parentheses is the big one. If I see the parentheses, and then if you want to be more specific, there's how many x's do you see on every single one? Just one. Yeah, this f of x doesn't count as an x, it counts as a y. So there's a single x inside of a parentheses, the parentheses being the big thing. Okay, so yesterday we identified A, B, and C. Today, let's identify A, H, and K. A, H, K. A, H, and K. A, H, and K. Sergio, which one do you like the best? A, H, or K? Me too. H. He said, huh, so I thought he meant H. It's my favorite too. Okay, let's look at the first one. What is A here? What number is in the A position? Yeah, I would agree with that. It would be 2. What number is in the H position?
3.
This is the biggest mistake that's made in vertex form. If you go back and look at the formula, what does the H have in front of it that none of the other blue letters do? It has a negative. So when you're looking at the function, and you've seen this dynamic before, when you have a negative in front of an unknown, you think you're seeing a number, but the number that's really there is the opposite sign. So if I go back here, because of that negative, if I'm seeing a +3, it's not really because H is 3, it's really because there's a negative 3 there. Long story short, change the sign. For H only for H. So if I see a +3, H is going to be negative. What's K here? -4. So instead of having to go and find and substitute and use synthetic substitution and all these other weird magic and stuff, they've given us a lot of the key information. What's the vertex going to be here? -3, comma, -4, because I didn't have to find h and k. I didn't have to use any formulas. It was just there. How about the owls? Axis of symmetry. Well, remember yesterday, axis of symmetry always started with x equals, and then x is going to be equal to whatever h is. So -3, good. It's going to open up or down. Very good. Y up. Yep. Let's go to the next one. What's A here? -1. Good. There's a negative in front of the parentheses. -1. What's H? +2. And what's K? What do you think, Jamin? Jamin, huh? It is +3. Good. Remember, you only change the sign for the H, not for the K. So, where's my vertex going to be? Vertex is going to be at 2, 3, H, K. Where's my axis of symmetry? X equals 2. It's going to open up or down? Y down. A is negative. So nobody calls you Ike? And then they can be like, I like Ike. He is my friend. All right, and then what's the A here on the next one? 1. Good. What's H? What's K? 0. Excellent. Sure, that's being added. If you don't see it, that's 0. Good. So, ¿dónde está el vertexo? It means where's the vertex? -5, comma, 0. Yeah. Fine. That's coordinate. -5, comma, 0. Where's the axis of symmetry going to be? X equals -5. And then it's going to open up or down? Oh. All right, you guys do the last one. Holla when you get it. Oh, no, he didn't. You got it already, Irma? Sneaky, Irma. Go. Well, first tell me what you got for H and K. Okay. Good. Excellent. So what'd you get for the vertex? Good. And then axis of symmetry? Show. Good. Well played, Irma. Well played. Believe that. I think I actually want to skip this next one because I think there's better ones. So let's skip the next example and let's go to this one here. I like how this maintains the same format as what we saw yesterday. The difference is we're still going to graph like yesterday. We're going to still answer all these questions. But instead of identifying A, B, and C, we're going to identify A, H, and K because this is in vertex form. How do I know it's in vertex form? The parentheses. The parentheses is the big thing. Okay, you see that parentheses? You see a single X? It's going to be A, H, and K. So A, H, and K. So what's A here? 2. Good. What's H? -1. And what's K? Now, I think I started doing this a little bit with you guys towards the end, but I did it more with my other classes yesterday, and I kind of liked how it worked. So what I want to try to do is, I'm going to graph this eventually, but before I graph, I want to try to answer as much of this as possible. Let's see how much of this we can answer without graphing. Do we know where the vertex is? Where is it going to be at? Okay, -1, -6. Nice. Do we know the axis of symmetry? X equals -1. Sweet. Hope is on fire. Do we know the domain? Yes, we do. What is it? All real numbers, also known as correct. Negative infinity, positive infinity. We know the domain. I said domain again. Sorry. Do we know the range? I know it. I know it. Yesterday I didn't know it because I didn't know the vertex from the beginning, but now I do. Hope, you want to give it a shot? Louis, you want to give it a shot? No. Yeah, Jamin. Yeah, well, see, this is opening up. A is positive. So you can actually write this two ways. You can say that the y, I like that you guys focused in on the -6. That was good. So you can say y is greater than or equal to -6. That's one way of writing it. But then if you are actually prompted to write it in interval notation, you would do a hard -6 with a bracket. It is touching -6. But then the positive infinity, because it's opening upward. It's going forever up, not forever down. Yes, ma'am. You open up. It does open up. That's good. And if it opens up, we have a minimum. Do we know where the y-intercept is? We actually don't. And see, I actually have more of a background teaching Algebra 2 than I do Algebra 1. I mean, I used to teach Algebra 1 years and years ago, but it was different back then and stuff. But from what I'm hearing from the Algebra 1 teachers here, is that this is actually a pretty common mistake. That you guys get used to standard form, and then you look at the number at the end, and you're like, oh, that's the y-intercept. And you put it as like -6, not in vertex form. In vertex form, you cannot identify the y-intercept. And that actually brings me now to, now I'm having a dilemma. Because now I'm debating as to whether or not I should even, because if we're going to find the y-intercept, we don't even need to use this. We don't even need to use that at the bottom. Yes. So, you bring this. Because this is a way that you can find extra points. But if we're going to have to find the y-intercept anyways, maybe we don't even need to use this. All right, we'll just leave it in the bag. Just meaning, like, I'm not going to emphasize this for now, and if anything, we'll come back to it. Okay? Now, vertex form isn't perfect, right? So, like, so far, wow, this has been great. I haven't even really had to do much of any work. Now, when you find the other points, that's where the work would come. You would either do the transformation, which is what I showed you on the first page, or if we're going to find the y-intercept, then we'll let that be the work. Okay. Now, what do we know about any point that's on the y-axis? What does every single point on the y-axis have in common? That x is 0. So that part we do know. And that's going to be the work. The way that you would find the y-intercept is to evaluate, substitute f at 0. Plug in a 0 for x. Oh, because of the parentheses here, now for here you can't use the fancy synthetic division, synthetic substitution. Yeah, because with the parentheses you can't do that. So yeah, you actually have to plug it in like the caveman did here. So this would be a 2, but then instead of an x, I would put a 0 plus 1 square equals -6. 0 plus 1 is? It is 1, yeah. 1 squared is, you gotta follow PEMDAS. Don't do 2 times 1 first. Leslie, 1 cuadrado. What's 1 squared? It is 1. And then 2 times 1 is 2, and then 2 minus 6 is -4. Yeah. she ain't about this life. So yeah, that's my y-intercept. Huh? Yeah, that's it. Like, see, so I guess technically the only time that you would, if we're gonna take this approach, the only time that you would need to use the transformation thing is if the y-intercept ends up being the same as the vertex, because it is possible to have a parabola where your vertex is on the y-axis. You know, and then so how would you come up with extra points in that case? You'd have to use transformations, but I guess we'll cross that bridge when we get there. Well, let's see. That's the only thing left to do now is graph, right? Would you agree that I've answered every question on the right?
Yes.
Does anybody not know how I answered one of those questions on the right? They need me to elaborate. Because if we can understand what's on the right, the only thing left to do now is graph. I only told you that we need 3 points. So, and the most important one is the vertex. My vertex is going to be at -1, -6. So -1, 1, 2, 3, 4, 5, 6. Now remember that the axis of symmetry the axis of symmetry, just like yesterday, goes right on top of the vertex. I'll put my y-intercept, which is at 0, -4. And how far away from the vertex is the y-intercept? So go 1 unit on the other side. One thing that I tried to, that I maybe should have emphasized more yesterday, I kind of don't care about this as much, but I have seen teachers that mark it wrong because of this. There is nothing that is straight about a parabola. So do not use a straight edge. And this is one of the hesitations I have about only forcing you to do 3 points. Is that when you see 3 points, you're just like, oh yeah, hey, let me connect the dots. Straight line, straight line. That's not a parabola. Now we don't have a parabola tool, so just do your best to draw it freehand. Just do your best to make it look U-y. Huh? Like a D? A deer?
Oh, it's
Ike didn't think it was cute. Ike did not like that. Did not like it at all. Any questions on that? All right, let's keep on going. Huh? No, actually, I just think that one out.
No, I didn't grab that one. I grabbed that one.
Do you mind looking at this one and say, whoa, Romero? Now you've just started to confuse me because you told me all along to focus on the parentheses, and Vicente's angry because he looks up here and he sees no parentheses. I get it. I feel your pain. I feel you. Yeah, but how many X's do you see? 1. So you can actually treat this, even though you don't see a parentheses, as long as there's only the X's being squared, you can treat this as, look, you can treat it as standard form also if you want. But we can also treat this as vertex form, meaning I can identify A, H, and K. The only thing is no parentheses means not that K is 0, but H is 0. Remember, because H is the one that goes in the parentheses. So if I don't see a parentheses, and I still want to treat it as vertex form, that means that h has to be 0. So that negative 3 that you see there is not an h, it's a k. Are you supposed to change the sign of k? There. H is 0. But see now, what you gotta be careful with is like, look, like let's say this would have said f of x is equal to x squared plus 2k minus 3. Yeah, there's no parentheses, but you see how there's two different types of x's? There is no way to consider that vertex form. Now, one of the things we're going to do at the end of the lesson today is I'm going to show you how to change that into vertex form, but you cannot consider that to have already been in vertex form. The point I'm trying to make to you is, if you don't see a parentheses, you can actually consider it if you want. You can approach it as if it's standard form or vertex form. Right? With standard form, we identified A, B, and C. I can identify A, B, and C if I want here too. The only thing is, now A would be 1, B would be 0, and C would be 3. It works either way. But when it wouldn't work either way is if I had like an extra term in the middle there that had an X. If B is not 0, if B is anything else, you have to change it into vertex form. Yeah. Oh man, B is always what's in front of X. That negative 3 is not in front of an X. If you look at the notes, it specifically says A is what's in front of X squared. B is what's in front of X, and C is always a constant, which is just a number. So let's see how many questions we can answer without graphing. Do we know where the vertex is going to be at? Where? Oh, wait, I'm sorry. What was A going to be here? 1. Oh, this is going to work out great. I'm glad I did this. It's going to be at where? 0, negative 3. Good. Where's my axis of symmetry going to be? X equals 0. Domain is all real numbers, so negative infinity, positive infinity. Okay, the range is going to have something to do with negative 3. Is this going up or down? Up. So this would be y is greater than or equal to negative 3. Or if you wanted to write this in interval notation, it would be it'd be a hard negative 3. Need a bracket because it touches negative 3. But then to positive infinity. Do we know if this is going up or down? Up. Meaning the vertex is a max or a min? It is a min. And do we know the y-intercept? We actually do. We actually do. Yeah, because in this rare instance, remember I was telling you that there's those rare instances where, but it is possible that your vertex is the same as your y-intercept. It is actually one of them. Yeah, remember? Because the y-intercept is the value of y when x is 0. So, well, that creates a problem because how many points do I need to graph? How many do I have? Just 1. I only have 1. I need 2 more. Okay? So I put this point here, but this point is not only the y-intercept, it's also my vertex. So I don't have anything to flip over the mirror. That's where the transformations come in. Okay? So what you would do then is go back to this first page, and you don't even need to the first page, you just know them, and pick any of these as starting points. I would advise you to stay away from the negatives, but pick either 1, 1, 2, 4, 3, 9. Huh? You want to use 2, 4? Okay, Hope says 2, 4, and whatever Hope wants you guys. You can use 1, 1, 3, 9, whatever you want. And we're going to write it down. We're going to say, okay, let's pretend that we're starting off at 2, 4, like Hope said. What is my x there? 2. In order to find a new point, what did I say on the first page to do with the x? Add the h. Well, what was h here? Yeah, it was 0. So, okay, 2 plus 0 is 3. Done. What's my y that I'm starting off with? Because Hope decided. Now, look, but look, you see, my favorite number is 7, like lucky number 7. But I was born on the 18th, so can I just use 718 instead? No. No, the only numbers you can start with are a pair of numbers where when you square the x, you get the y. Like 1, 1, 3, 9, 4, 16. You got to start at any one of those. We like Hope, and Hope picked 2, 4, so that's why I went with 2, 4. But you could use 1, 1. It works also, yeah. Okay, well that's the next thing I was gonna ask. So for the y's, we would start with 4 because that's the y we have, and then on that first page, what did I tell you to do with the y's? Times a, but a is 1, so times 1, and then plus k, which is -3, so that's -3. So now let's see what we end up with. 2 plus 0 is 2. 4 times 1 is -3 is. So now I can put 2, 1 on the paper.
That's easy.
And then I can flip that over. So 2, 1 is here. How far away from the blue line is that? How far away? Use your words. 2 units. So go 2 units on the other side like a mirror. And then parabola it up. Draw a deer. Just make sure that the lines aren't straight. Like I have seen before, I've tutored kids where they don't take my advice and they decide to draw straight lines because they love straight lines and the teacher marks it wrong. Any questions there? Sergio, any questions for you? Okay, you let me know if you do though. You can ask Leslie also. She's all right, nice. What form is this in? Vertex form, sure. I see the parentheses. Yay, parentheses are back again. I just do so. So I can identify A, H, and K. What's A gonna be here? -1. What's K? What's H gonna be here? Also -1. Remember to change the sign. What's K? 6. So let's see how much we can answer without actually graphing. Lana, where's the vertex gonna be at? Maybe. Vertex. -1, 6. Good. Jamin, where's the axis of symmetry? What's the equation of the axis of symmetry? For sure. Alphas, what's the domain? Well played, sir. You can write, as long as you're not being told specifically how to write it. If you were to just write all real numbers, that's cool with it. I'm fine with it. We're cool with it. But I like to live dangerously, so I'll write it in interval notation. Yes, Hope. Brian, you want to take it? The range, do we know the range? El Rango. Say that again? No. Yeah, you can say y is less than or wait, but on the last two that's been greater than or equal to. I don't get it. Why is this one less than or equal to? It's going down. It's pointing down. Facts. Yeah, because the vertex is the max, sure. Now, if you wanted to write the range in interval notation, the way you would describe the set of numbers from 6 going down, you'd actually have to write the down part first because you're supposed to go from down to up. So -infinity up to 6, and then close it with a bracket. Do we know a y-intercept?
No.
Nah, not on this one. Not on this one. So we're gonna have to find that one algebraically. But what we do know about any y-intercept is it's the value of y when x is 0. So let's evaluate this function at 0. I don't have any fancy tricks for you today. It's just good old-fashioned substitution. 0 plus 1, 6. 0 plus 1 is 1. But you have to square the 1 before the negative comes in. So if I square the 1 first and then I get the negative, I actually end up with negative 1. And then plus 6 is 5. Negative 1 plus 6 is 5. So my y-intercept is going to be at 0, 5. I would then draw my vertex. Negative 1 comma 6 is 1, 2, 3 here. Then, I hate this. They're so close together. I hate it when they're so close. There's the y-intercept. So if you imagine the axis of symmetry going through the vertex, and I flip the script, now my parabola, something like that. For the record, a parabola never goes straight down. It always is opening up. All right, since I already got my 10-minute warning, I actually want to skip two examples from yesterday's notes. These are not going to show up on these notes. These were at the end of yesterday's notes. But again, I normally teach these in reverse. So I had them on yesterday's notes instead of today. So as long as you have yesterday's notes and you're a good boy or girl, keep good notes and stuff, you'll be able to do this. What form is this function written in? Standard form. The directions take change the vertex form. There's two ways to do this. We can actually do this. What numbers can I identify when I'm in standard form? A, B, and C. So we can actually like individually. What values would I have if I was in vertex form? A, H, and K. So I can teach you how to turn an A, B, and C into an A, H, and K. That's the way I'm gonna do it. Because the other option involves completing the square. Is anybody nostalgic here and this is really wants to go back to completing the square? No. And yeah, it can be done both ways, but I've done this before, and I find the children are more successful doing it this way, where we just turn A, B, and C into A, H, and K. What's A, B, and C here? Or first off, why is this in standard form? Why is this in standard form and not vertex? Oh, you can say there's two x's also, there's no parentheses, right? So yes, A, B, and C is going to be here 1, -4, and 6. And I need A, H, and K. Well, here's the good news. A transfers over. I told you at the beginning of this lecture that the A from standard is the same as the A from vertex. So, nice. Take a wild guess how we're going to find H and K. I'll give you a clue. I'm actually not teaching it to you today. I taught it to you yesterday. Good. We learned that that H was going to be negative B over 2A. So if B is -4, this would be 4 over 2 times 1, which is 4 over 2, which is 2. I know that H is going to be 2. How do I find K? You could plug it in if you want. Hope. You can do synthetic substitution if you want also. Hey, watch that. Let's just do it that way just to mess with you. Let's just only do synthetic substitution. And if you don't want to do it that way, you can plug it in yourself and see if we get the same thing. What number do I want to plug in? 2. So I'll put that on the middle balcony. What's A, B, and C? 1, -4, and 6. The K that I want is going to end up down here. All the way underneath the... Okay. Start with the first number that's on the balcony. Okay? No, that's not on the balcony. The 2's on the balcony. So get the 1 and drop it as if it was hot. Because really, every single time that you drop straight down, you're adding. So you don't realize it, but what's underneath the 1? What's underneath the 1? Nothing. There's nothing there. What's 1 plus 0? 1. Now, every time you want to get back above, think of it like, did I give you the whole Rapunzel example? This is like little Rapunzel letting down the hair and trying to lift them up. So, since this is the number here that's trying to pull the number up, every time you go up, it's going to be multiplication, and it has to be multiplication with that number. But when you go back up, don't go straight up. Go up to the next column. So what is 2 times 1? 2. Put it here. How do you go straight back down? You add. So I give you -2. What's 2 times -2? -4. What's 6 minus 4? 2. But mister, I don't want to get that way. Don't make me. Okay, don't do it. It's fine. Did anybody, I know a lot of you guys like to go off on your own. Did anybody substitute, like plug it back into the original? Because if you did, you should have gotten 2. So now the only last thing to do is actually to go ahead and write it. So I'm going to write y equals, if I'm plugging into vertex form, what goes first? A 1, the first thing that comes is A, but when A is 1, yeah, I'm supposed to put the 1, but if a parenthesis is coming next, do I have to write a 1 in front of a parenthesis? No, so yeah, think of it as, yeah, the 1's there, but the second I put the parentheses, I don't have to write the 1 anymore. So I'm just going to put the parentheses. Okay, then it's x on the inside. What comes after the x? H. But if h is 2, you're not going to see a 2 here. What are you going to see? A -2. Then a very common thing, even me, even Tweedledum over here myself, I make this mistake all the time, just careless. I forget to put the square. Yeah, put the square. And then finally, what goes on the outside? K, which is +2, and ta-da, vertex form. Whoop, whoop. Whoop. Here, one more real quick. What's A here? -2, what's B? What's C? Okay, so I know that the A is going to transfer over, but I don't know H and K. So H is going to be -B over 2A. -8 over -4 is +2. Then you can do K however you want. You can do it synthetically if you want, or you can plug it in. I'll just do synthetic again. So I'm going to plug in a 2, and my A, B, and C were -2, 8, and 3. Hope, drop the -2. Then multiply with this 2 to get back up, which is -4. Add, which is 4. Multiply, which is 8. What's 8 and 3? 11. That last 11 is going to be K. So now I have y equals, write it in the same form. How do I, yeah, y equals. If it was f of x, I would write f of x. What's going to come first? -2 because it was a, parentheses. Then I write my x. If h is 2, what am I going to write on the inside? -2, and don't forget the square. And then what's k? +11. Ta-da!